exercise 3A on expanding and collecting like terms on page 82. We're going to start looking at quadratics. It's essentially linear equations to the next degree. That's a pun, but you guys don't get it yet because we haven't covered yet. All right, so what we're looking at is a polynomial function. What does poly mean? Multiple. Perfect. Polygon means multiple sides. Polynomial means multiple nomials, right? So looking at what happens if we bring up the power. So when we have a linear equation, we have y equals to x plus 3, let's say, right? What is the power of the variable x? 1. Awesome. Now the question is, what happens if I bring that, let's say y equals to x squared plus 3? What happens to that line? Does it change shape? Does it do something wacky? Well, it does. But the idea is what happens to that, and especially algebraically, what happens to it? We'll look at this, what it means geometrically later on in terms of what it looks like as a graph, but let's focus on the algebraic aspect. So a polynomial function is any function where we have that variable being to a power of something. So we're looking at what happens if we bring up that power. In math terms, we say we bring up that degree. So the degree is the power of the highest value there. So let's say, for example, I have y equals to 3x squared plus 4x to the power of 7. I would focus on the one that has the highest power. And so the one with the highest power would be 7. So therefore, it would be the 7th degree. Does that make sense? Awesome. Do you guys remember what coefficients are? Yeah? No? Coefficients are just the numbers in front of the variable. So for example, in this one over here, I'm looking at the coefficient, and I'm saying, okay, the coefficient is going to be this number here, so 3. It's also going to be this number here, so 4. So the coefficient is just any number in front of a variable. Okay? Now, when focusing on expanding and collecting like terms, we're not going to be purely looking at linear equations anymore. Remember that just as how 4x is not a like term to 4, 4x squared is not a like term to 4x. So we have to keep that in mind. So let's go ahead and do our first example. Pretty straightforward. Let's go ahead and expand. I'm going to give you guys a little bit of time to do this. No, I'm not. I'm going to do it as a class. I apologize. So expand 2x bracket 3x take away 2 plus 3x x take away 2. It's a bit of a confusing one there. Alright, so expanding 2x bracket 3x minus 2, we have to use understanding of distributive law. In other words, let's just go ahead and multiply them. 2x multiplied by 3x, what's that? 6x squared, good. We've got the squared over there because there's 2 x's there. 2x multiplied by negative 2 gives me negative 4x. And then I add 3x multiplied by x. 3x squared, good, there's 2 x's. 3x multiplied by negative 2. Negative 6x, good. Now, once I've done that, I need to go ahead and collect the terms. So I'm going to say that that equals to, do I have any like terms? Yep, so I've got 6x squared plus 3x squared gives me 9x squared. I've got negative 4x, take away 6x gives me negative 10x. Any questions? Pretty straightforward? Awesome. Let's go ahead and now do some FOIL. You guys remember FOIL? Yes, no? Yep. So let's go ahead and do an example. Let's go x plus 3. Oops. X, there we go. Plus 3. And then 2x take away. God, my computer's not liking me today. I do apologize. Plus 3, there we go. And then 2x take away 3. If we're trying to expand that, what do we notice is different between this expansion and the expansion from the last question? Why do we have to use FOIL in this question, not the other one?
Because there's 2 different parts to expanding.
Awesome. So for this one, we've got this term, and this term. We'd say this multiplied by that, and then that multiplied by that, and we're done. However, with this one over here, we've got 1, 2, 3, and 4 terms over there, in which case I have to go 1, 2, 3, and 4, right? It gets a bit confusing. So what we do is we just do something called FOIL. FOIL, we know stands for, F stands for first, outer, inner, and easy. First, outer, inner, last. So I'm going to multiply those terms as they show up. Alright, so over here I'm going to multiply my first two terms. So x times 2x gives me 2x squared. I'm going to use different colors to show you guys, by the way. So that's first and second, outer, sorry. I multiply x by 3, but is it, thank you, x by negative 3. So I get x times negative 3 gives me negative 3x. Up next, I've got inner. I've got 3 times 2x. So 3 times 2x is plus 6x, good. And lastly, I've got 3 times negative 3, which gives me negative 9. Am I done?
No.
Why not? Like terms, 2x squared. And then the only like terms I have are negative 3x and positive 6x, which gives me positive 3x, take away 9. And therefore, we get this equation over here. You guys have already done FOIL. That's what happens when we have two variables in each one when we're multiplying. So two terms, apologies. What happens when we're multiplying and expanding ones with multiple terms? So can I go through this question over here? I do apologize, I know it's quite long. Plus 4. I'm going to say, let's try and expand 2x, take away 1, multiply by 3x squared plus 2x plus 4. So from here, we're no longer using the FOIL idea. FOIL idea only applies when we have two variables. Now we have to go ahead and try and expand it using our own understanding. So what was the point of FOIL? Why do we use FOIL? Does anyone know? Well, the idea of FOIL is that every term in this section over here, in this bracket, needs to multiply by this term over here. Using FOIL, we know that this interacts with both this term and this term over here. And we know that this term over here interacts with both of these terms on this side over here as well. So the question is, how do we do that when we have multiple terms in that, more than just two? So I'm going to go ahead and multiply this variable by that one, and then that one, and then that one. Does that make sense? Yeah? So 2x, let's do that first actually. 2x multiplied by 3x squared, 6x cubed. Okay? So the idea is I'm multiplying by the coefficients first. I'm going to write them unexpanded first. So 2x multiplied by 3x squared. We do that later. And then from there, moving on to the next term, plus 2x times by 2x, because I'm multiplying these two terms now. Are we okay with that? Up next, I'm going to multiply this term and the last term. So, plus 2x times by positive 4. Are we okay with that? Okay. Now I'm doing the same thing, but I'm going to do it with this term. Multiply by this, and then that. So, negative 1 times by 3x. And then negative 1 times by 2x, and finally negative 1 times by 4. Thank you, negative 1 times by 3x squared. Any questions? No? Let's go ahead and simplify it. So now I'm going to multiply those coefficients together. The coefficients multiply give me 6. And now I've got x and x squared. Remember that x without a power is just x1. So x power 1 times by x power 2. It gives me x power 3. Did you guys do a bit of that stuff last year? Multiplying those terms? Yeah? Okay. So x power 3. 2x times 2x gives me? So if I multiply the two coefficients, I get 4. And then x times x is x squared. Yeah? Okay. I need a little bit of feedback, guys. I know you guys are tired. I'm also tired. I need a little bit of feedback. 4 times 2x, or 2x times 4? 8x, thank you very much. Now let's go ahead and simplify the blue font. So negative 1 times by 3x squared gives me negative 3x squared. Negative 1 times 2x gives me minus 2x. Negative 1 times 4 gives me negative 4. Now I go ahead and simplify. I know it's a big question, I do apologize. I simplify. I'm going to go ahead and say, well, it's 6x cubed. Is there any other term that's similar? No. I'm going to get 6x cubed by itself. What about 4x squared? Yep. So I'm going to get 4x squared. So I'm going to say 4x squared take away 3x squared. Just gives me 1x squared or just x squared. 8x, I've got one that's over here. So 8x take away 2x. 6x, thank you. And then I end up with a minus 4 at the end. Okay. Any questions? No? Awesome. I'm going to pause recording there. I know I've been talking for a long time. Can I ask you guys to get started on working on exercise 3A for me? Thank you.